Alright class, today's lesson is on multiplying fractions and mixed numbers. So what we're going to be doing today is looking at, it could be just normal proper fractions, where we're doing things like 2/3 times 4/5, so proper fractions, or we're also talking about mixed numbers, so it could be something like 2 2/3 times 1 5/6. Alright, either one, that's what we're doing today. The big key today, though, is that we do not need common denominators. That's I put right here for you guys to see. All right, if we happen to have common denominators, that's okay, but we do not need to change our fractions over like we did when we added and subtracted fractions. So for today, the big thing is we don't care about common denominators. We don't need them when we're multiplying. Okay, so example 1, example 2 here. I'll do example 1 for you, and we're going to go through our checklist of rules. Okay, so example 1, we're doing 3/4 times 1/2. Okay, our rules. Again, I wrote here for rule number 1, we do not need common denominators. Well, good, because my denominators are 4 and 2. I don't care that they're different. I don't have to change these over. That's a big difference between adding and subtracting, where you have to have common denominators, and then multiplying, where you do not need common denominators. Okay, rule number 2, multiply the numerators. So on top, 3 times 1, well, that's easy enough. That gives me 3. Okay. Step 3, multiply the denominators. Okay, on bottom, 4 times 2, that gives me 8. Easy enough. And then step number 4, as always, always simplify. In this case, 3/8 is simplified. We're done. That's all multiplying is. So what I want you guys to do is pause the video and try number 2. Okay, hopefully you're back. Here's what you should be doing, going through our checklist. I don't care that our denominators aren't the same, 4 and 9. That's fine by me. Multiply my numerators. 1 times 7 is 7. The denominators, 4 times 9 is 36. Okay, I have to check to see if I can simplify 7 over 36. There isn't anything that they can both be divided by, so my simplified answer is 7 over 36. Okay, here's another one for you guys. I want you to go ahead and pause the video. Try it on your own. Okay, so if you're doing this the same way, what you probably did was this. Multiply the numerators. 5 times 7, which gives us 35. And then the denominators, 6 times 10 gives me 60. Now when you go to simplify, you realize, well, they both end in a 5 or 0. That tells me I can reduce these by dividing by 5. Okay. 35 divided by 5 is going to give me 7. Okay. 60 divided by 5 is going to give me 12. And that is my simplified answer. Okay, now that's what most of you probably did. Now, I want to show you one other little trick of the trade here that helps us do this. Now, I'm going to go ahead and rewrite this problem again. I'm going to show you something that I want all of us to be looking for when we're doing 5/6 times 7/10. Okay, and I'm going to type in a little rule over here on the right. So watch for the rule to pop up. And there it is. The rule says, when multiplying, you can reduce any numerator with any denominator. So what that means is when I have this problem 5/6 times 7/10, I know I can do it just like I did up top. Okay, we all get how to do that. But there's a little trick of the trade here when we're multiplying 5/6 times 7/10. Now, first of all, you got to make sure that it's a multiplication. This little trick does not work with dividing. It does not work with adding and subtracting. It's only when you are multiplying fractions. Okay, and the rule says this. I can reduce any numerator with any denominator. So that means I can look at things like 5/6. Say, can the 5 and 6 be reduced? And the obvious answer is no. But we also want to look kind of across from each other like this. 5's a numerator, 10's a denominator. Can I reduce 5 and 10? Just like if it was the fraction 5/10. Yeah, well, of course we can reduce that. Okay? So we're going to do that same thing here. What I'm going to look to do is reduce both the 5 and the 10 by dividing them by 5. So if I go 5 divided by 5, that becomes a 1. If I go 10 divided by 5, that goes a 2. So I'm dividing both of them by the same number. Okay? Now, once I do that reducing before I multiply, now I can go ahead and finish the problem, just like before. The numerators, 1 times 7 gives me 7. The denominators, 6 times 2, gives me 12, and you'll see that we get the same answers before. But by reducing before we actually do the multiplication, what happens is it saves us sometimes from working with some large numbers. Okay, now 35 over 60 wasn't too big, but sometimes they get quite large, and then it's harder to reduce. We want to look to do any of these cross-reducing before we actually do the multiplication. Okay, here's one for you to try on your own. So look for things that you can reduce, and then do the problem. So pause the video. Okay, you're back. So I'm looking really for things that are across from each other here, like the 4 and the 8. Well, I know both 4 and 8 can be divided by 4, so I'm going to divide both of them by the same number. Divide the 4 by 4 and you get 1. Divide 8 by 4 and you get 2. But I'm not done yet because I also see the 3 and the 9. Okay, so divide both of those by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. And let's go ahead and do that. Numerators, 1 times 1 is 1. Bottom, 3 times 2 is 6. And we get 1/6 as our final answer. Now, before we move on to a new problem, I'm going to rewrite this. And I want to show you one little neat trick here. 4/9, and we're multiplying by 3/8. Now, let's just say that you happen to notice one of the things that you can reduce, but not the other. Let's say that you said, okay, I know I can reduce 4 and 8. That becomes 1 and 2. But you missed the 3 and the 9. Well, watch what happens here. If I multiply, okay, 1 times 3 is 3. The bottom, 9 times 2 is 18. And you might say, well, the answer is 3/18. Well, I missed the 3 and the 9 there. But that's okay, as long as you realize still that when you get your answer, you might have to reduce. I know I can still reduce those by 3, and I'm still going to end up getting 1/6. So you can still get a correct answer even though you might have missed some of the cross-reducing. You just got to be careful that you want to reduce at the end. Okay, mixed numbers, okay? And I have our rule right here. Our rule says no matter what, if we're working with mixed numbers, that we change all mixed numbers to improper fractions, okay? So what that says is when I see 2 3/4, I have to change that. So remember how we do it. We go 4 times 2, which is 8, and then plus the 3 gives me 11/4. So I change that to an improper fraction, and then the 5 over 22 is okay, and then I can do that problem. Now I want to show you something off to the side here, because what we did when we added and subtracted things was this. If I were adding these two things, remember we did it like this. We would do the fraction parts first. 1/2 plus 1/2 is 2/2, and we do then the whole numbers. 3 plus 2 is 5. Okay, that's not what we're doing here today. I'm not going to treat this as do the fractions first and then the whole numbers. It is different when you're multiplying. Mixed numbers will become improper fractions, and then we can go. So I'm going to go back down and finish this problem. 11/4 times 5 over 22. And what I notice is that 11 and 22, okay, that can turn into 1/2. So I change them to 1 and 2. Okay, numerators, 1 times 5 is 5. Denominators, 4 times 2 is 8, and I get 5/8. Okay, so last problem of the day, I want you guys to try part B. Start by changing them to mixed numbers, then finish the problem, and then come back and watch my answer. Okay, here we go. So I'm going to change both of these into a mixed number. So 5 times 4 is 20, plus 4 is 24/5. Okay, 9 times 1 is 9, plus 1 is 10/9. So there's the new problem, 24/5 times 10/9. I'm going to look to reduce. I see a 5 and a 10 that are diagonal from each other. Divide them both by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. Okay. I also see the 9 and 24 can both be divided by 3. 24 divided by 3 gives me 8. 9 divided by 3 gives me 3. Now I multiply. The top, 8 times 2 is 16. The bottom, 1 times 3 is 3. Okay, I got to remember that this isn't my answer because it's an improper fraction. I always want to change it back to proper form. I know that 3 goes into 16 5 times. That gets me to 15, so I'm 1 away yet. So I have 1 extra out of 3. 5 1/3 is my final answer. That's our lesson for today.